Okay, day 5, question 9. A relation between x and y values is shown. Does the relation represent a function? Okay, remember when we're talking about functions that it's all about that x. All right, so I'm going to cover up my y's because I only care about the x. So do I have more than one line coming from any number? No. So this is a function. Okay. All right, so does the relationship represent a function? Yes, it does. So I can get rid of f and h. All right, so does it represent a function because each dependent quantity is mapped to only one independent quantity? Well, I have to know what those words mean. Or is it because each x value is mapped to only one y value? Well, the x is the independent because when we put it in, we're telling it what numbers to use. And the y is the dependent because the y value depends on what the x value was. So is it a function because each dependent is mapped to only one independent? No, because it's all about the x. J says each x value is mapped to only one y value. That is true because we only care about the x. All right, number 10. Which algebraic representation best describes the transformation used to create the triangle A prime, B prime, C prime? So what I would do is find one point to compare because all of this, I have a hard time remembering all of this, okay? I do know that when the x is negative, that this is a reflection over the y-axis because the y doesn't change. And I do know when both the x and y turn negative that that's a 180-degree rotation because I just remember that one. So I'm kind of down to these two choices. But what I would do is just pick a point. So point C is on 1s. So I'm not going to use it. I'm going to use point B. So point B is at 6 and 2. All right, so it's at 6 and 2. And B prime is at 2 and negative 6. So by looking at where we started to where we ended, I want to know what happened. Well, this is my x, this is my y. Well, they switched places, all right? And the x changed opposite. It changed to negative 6. So the one of these that says that is this one right here. The y and x changed places and the x turned negative. So I would just pick a point and use it so you can tell. All right, day 5, question 11. Which model does not represent a solution of 4? So x is equal to a positive 4. Normally with these model questions, I would just use them to write the equation, but these actually do kind of help to have the models because if you have the same thing on different sides, you can just subtract them away. So since I have 3 x's here, I can get rid of 3 x's here. And I have 1 negative here, so I can get rid of 1 negative here. So now I have 1 x, and I have these 4 negatives, but I have nothing over here. So when I add 4 to both sides and zero that out, I'm going to wind up having my 4 positives over here. So in this case, x is equal to 4. On this one, I have 2 x's here, so I can get rid of 2 x's here. And I have 2, 4, 6, 8, 9, so I can get rid of 5, 6, 7, 8, 9. So now I have 1, 2, 3, 4 x's, and I have 5, 10, 15, 16 over here. And then when you divide by 4, x equals to 4. So f and g both equal 4. H, I can get rid of this 1x and that 1x. I have 5 positives here. I can get rid of 5 positives here. So I have x plus 4, and then it's equal to 0. So when I move this 4 over, it's going to turn negative. So this one does not equal positive 4. On J, I have 3 here, so I can get rid of 3 here. I have 2, 4, 5 here, so I can get rid of 5 here. So I have these 4 positives that equal to this 1x. So the only one that doesn't equal 4 is H, because it equals to negative 4. All right, question 12. Parallelogram UVWX is dilated to form parallelogram UVWX prime. Which best represents the dilation of parallelogram UVWX to parallelogram UVWX prime? Well, it's kind of hard to see, but the inside one is your original, and the outside one is the prime. So since it's going to enlarge, I know it can't be A or C because those are multiplying by fractions, which would make it smaller. So it's either going to dilate by 2 or dilate by 3. So my scale factor is new over original. So I need to pick a point. And I'm going to use my y's because the x's wind up with some half values. So for v, the original v is 2, and my new v is 4. And 4 divided by 2 is 2, so that makes it 2x and then 2y, because I'm multiplying all of these points by 2 to get my enlargement. All right, 13. The student council members are making decorative labels to cover 20 identical empty coffee cans for a charity drive. Each label will cover the entire lateral surface area of a can. Which equation can be used to find the lateral surface area for all 20 cans? All right, so I need to use my handy dandy reference material. My shape is a cylinder. I need surface area. I need lateral surface area. So here's my formula. Surface area is equal to 2 pi r h. All right, so 2 just stays 2. Pi stays pi. The radius, oh no, it's a fraction, but we don't actually have to multiply this out. We're just matching it up to the equation. And the height is a fraction, but no big deal because we're just matching it up to the equation. So this is going to find me the surface area for 1 can. But my question is for 20 cans. So each of these formulas have to be multiplied by 20. Well, A has 20, C has 20, B and D do not. So A has 20 times 2 pi times the 3 and 1/16 times the 6 and 5/8. So that's going to match up.